Alrighty, welcome. Today we're going to be demoing our instructions on building the Silvermint infrastructure. So we're just going to walk through that today. So I'm just going to kind of review our document here that Rusty has made for us. As you can see on the screen, this is titled Building the Silvermint Infrastructure. At the top of the instructions, we've got some lists of information for you, some technologies that we're listing here and the purposes of what we're doing with them, the components. We have list of cloud costs. But what we're really here to do today is show the deployment configuration. So scroll down to that. Alrighty, so the deployment workstation will need Debian 11 plus installed. We recommend a fresh install. Back here you can see my terminal. This is my fresh install of Debian running. And we're using a Docker container. So what I'm going to do is I'm just going to walk through the steps here to show you how it works. I'm pretty fresh at this, so this will give you a good idea of how simple this is. So, alrighty. So I already have it launched. So we now need to update and install sudo. So what we do is just copy it, paste it into the. Oh, it's going to yell at me. Should use the right. Let's try that again. That's not what I wanted. Okay. I don't know why it's giving me. Looks like that copy isn't copying just the part that we want. Or I am not using my keyboard correctly. Alrighty, Rusty, any suggestions here? Am I just... or Nash?
Sitting here talking into mute. Sorry about that. You should just be able to paste Command V into your terminal.
Why am I getting the weird...
I don't know. It's like it's picking up some markdown characters, maybe. Try just selecting the text on the screen as opposed to hitting the copy. That's bizarre. That didn't happen to us at all in the previous rounds. Are you using a different terminal than normal?
No, this is exactly the same thing we did last time.
Same result, huh?
Yeah. Let me start over. Let's just... Alrighty. Okay, so we're just gonna start fresh. Yeah, see, look, right there. Copied and paste correctly.
Oh, yeah, it's grabbing the bin bash for you. That's not going to work in Darwin.
Alrighty.
There you go.
Trial and error. There we go. Okay. Now let's try this. Look at that.
At least you got it done.
There we go. All right.
When it doesn't work, start and try over. Alrighty.
That's right.
Okay. So now that we have that up and running, sudo installed, now we're going to continue configuring here. So we're at the deployment workstation step. So at the bottom here, you'll note that it says you'll need to add your public and private SSH keys to access Google Cloud. So this step has already been done on my system. So just need to take the code, copy it, paste it in, run it. So right now we're just installing the Google Cloud CLI. We're installing Terraform, installing Git. These are the tools we're going to use to start up our network in the Google Cloud. So just takes a sec. Alrighty, that has been run. So now we're on the step of the Google Cloud project configuration. So we're doing it from the deployment workstation. And you'll see here, it says the step requires the following permissions in Google Cloud: organization administrator and billing account administrator, which those have been set for my account. So now we're going to copy the next set of code and paste that in there. Alrighty, so now you'll see here in the terminal that it's going to tell us to go to the following link in your browser. So we're just going to select that. And then we're going to come into the browser and head over to the accessing of the Google account. So you'll see here it asks for permissions. We're just going to allow those. Now we're signing into the Google Cloud CLI. So we need to copy the verification code here. Then once this verification code is copied, we're going to bring it back here. You can see here it says enter authorization code, and we're going to paste that in there. And now you can see here, you're now logged in as Andrew at PyroFix.net, showing my account. And then we get to enter the name of the Google Cloud project to create. So we're going to just call this Andrew. Let's call it Andrew Net.
And you'll not want to use underscores.
So no underscores. That's a good
Yeah.
one.
Yeah. Stay with hyphens. Google Cloud is not a fan of underscores.
Probably don't want to show that.
No, we actually do.
So
what we're doing there is we're showing the billing account ID. A lot of the time in Google Cloud, you'll actually have multiple billing accounts associated with multiple projects. So what that is we list the billing accounts ID, and then you can select it and paste it there.
Okay. Yeah. Alrighty, now it's just going to process the account setup. Alrighty. So once this is completed, then we're going to go to the supporting infrastructure.
And during this step, this is essentially enabling all of the background services required to interact with the infrastructure you're going to build. This enables APIs, sets default zone, creates service accounts, associates permissions with those service accounts. So this is this is preparing your Google environment to do all of the work we're going to do in the coming steps.
Did you guys explain to folks what's going to happen over the course of this, what they're going to get at the end?
No, I missed that step. I kind of talked about it at the beginning, just mentioning that we're showing deploying a network, but not in extreme detail.
Yeah.
Rusty, if you want
We can do that now, though. Yeah, so this doc, essentially this doc is the Silvermint validator network in a box. It allows you to take a blank slate Google Cloud project, and it implements all of the different services, controls, project settings in the Google Cloud environment, and it then creates all of the server and network infrastructure that you'll need to successfully run a Silvermint network. And then as the final step, it actually deploys the source code from our gitlab.com repository and deploys the set of servers that you choose to deploy. This is currently built to deploy 5 servers across the globe, and the network is designed for that. You could modify this. You can change the number of hosts that you want by simply, if you go to the very bottom, by simply modifying the configuration for the Terraform variables at the bottom. We'll get there. But yeah, this is the quick start version of how to get a Silvermint network up and running.
Alrighty, now
and the end result, sorry,
Rusty.
I was going to say the end result is a Silvermint network that you could run transactions against. You can create wallets and do payments back and forth between wallets. Go ahead, Andrew. Sorry.
No, you're good. The Google Cloud configuration step is completed, so now we're on to starting up supporting infrastructure. So here we're setting up the routers in the different locations, and Prometheus and Grafana. So all of our network. Alrighty, here we go.
So like Andrew mentioned, we're setting up the network here. We're setting up firewalls and the associated rules for each piece that's going to be implemented. We're also installing Prometheus, which we use for our metrics engine. And then we're installing Grafana, which we use to visualize those metrics into dashboards to create a visual understanding of what's happening in the network and how things are going. The Grafana piece is pretty critical in the visualization. There's a lot that is happening, but without that dashboard element, it's difficult to actually see or get a sense of what work is going on and how well the network is running. So this is probably the longest step in this process, but we figure the full process from end to end, once you've done it once, it's about a 30-minute process. So in 30 minutes, you'll go from an empty Google Cloud project to a functional Silvermint network.
I believe we should be able to see that project in the Google Cloud now.
That's correct.
Yeah, so let's do that. So if we come over to your Google Cloud, we can view the projects, and we can see here we have my project set up. So if I click on that, we can see the project information, and we can come over to our VMs here and see this is where all of our VMs are going to show up as this step completes. And then we're going to start setting up Prometheus and Grafana in the Google Cloud. So slow startup there.
Yeah, this is a point where we could probably work to optimize a little bit, but what we've done is we've created the Prometheus instance. You'll be able to see it in the instances, but because we're using GCE Discovery to actually automatically identify the Silvermint validators as they come online via Prometheus, we have to modify the scope that's associated with the Prometheus machine and give it the ability to view all of the infrastructure inside of the project that it's in. So it comes up and then we have to stop it and apply that scope. I would wager if we spent some time, we could find a way to apply that scope before starting it or create it but not start it. So, but that's what it's doing right now. It seems to take quite some time to stop.
Just to be clear, that's a Google Cloud thing.
Yeah.
That's
right.
correct.
Yeah,
That's correct.
a lot of the complexities. So, for the studio audience, if you find that some of this seems a little complicated, most of that's Google Cloud. The Silvermint node itself is just a Linux machine and a Debian package and a config file. And getting it to come up automatically takes a little bit of effort in the cloud.
That's correct. And you'll see that when we get to the last panel where we actually begin deploying our code. It's something like 10 or 12 lines and that's it. It's, the Silvermint aspect of this is incredibly easy and incredibly straightforward. Getting all of the supporting infrastructure built up in Google Cloud is much less so. And I think that's true across the board. Were you to use Azure, AWS, it doesn't make a difference.
Right. I think so too.
And so you'll see here that we're installing Redis, and Redis is a component of our validator orchestration. It is just a temporary component for us. As we continue to launch features into the Silvermint network, we will actually be retiring the Redis as an orchestration component here. But for now, we use it to orchestrate the starting up of the Silvermint validators. We bring everything up online, they all reach an active state, and then we start all of the services at once. So very little reliance on Redis, and in fact, none at all for the Silvermint network itself. I feel like we should have prepared some entertaining music. This step is lengthy, for sure. So
Let's see. We have 0 viewers, so doesn't matter. This is practice.
Yes, it is.
Yeah. It's a shame too, because this is a pretty significant achievement. I mean, the ability for us to launch and start from a blank slate and run a network at speed and have it all done in an automated fashion is pretty amazing.
Yeah.
And how quickly and easy this is too.
Yeah.
Oh boy.
Nice part, Marcus, when you edit this is that it will be much, much faster. Fast forward in time.
Why is it still line API? What the hell?
Yeah, this is a little lengthier. Andrew, I feel like this is. Oh, there we go.
Right as you guys
And
complained
it
how long
works.
it was, it's like, oh, I'm going to finish now. All
They
righty.
figured out an algorithm for the delay. Okay, great.
Okay, now we get to do some Prometheus server configuration. So like I said earlier, we're going to do this in the Google Cloud. So if we go back to our instances here and we refresh this page, we're going to see Prometheus and Grafana showing up here. So now we're going to go into Prometheus. Just wait to connect to its server. Alrighty, so now we're in Prometheus's terminal here. So we're just going to continue to follow those steps. And this note will be important here when it asks us for the project ID. But first, let's copy this and paste this into the terminal. Now again, making sure that this is done in Prometheus, not in your deployment or Grafana in Prometheus's terminal, or the VM for Prometheus. Right here. So right here, you'll see it says enter the Google Cloud project ID. So we're just going to go back to our Google Cloud here, and we're going to go to our dashboard, and our project ID is right here. So we're just going to take this and copy it. Paste that in. Now it's going to continue to set up Prometheus. So let's go back. Go back to our VMs here. Alrighty, so while this is going, we can now also, if I remember correctly, Rusty, we can also set up Grafana at the same time.
That's correct. That's correct. These two can be done in parallel.
Awesome. So while this one's working, we can work on the next step. So it's basically the same. We're going to go to Grafana here. We're going to open up its terminal. And we're going to copy and paste the code in here.
And on both of these, what we're doing is setting up the servers themselves. So we're installing Docker, we're installing we're pulling down the different containers for Grafana and Prometheus and the supporting bits for that. And then we are applying a configuration to them that connects to the network that we've just created.
Yeah. You'll see here it asks us for the internal IP address of the Prometheus server, not the external, internal. So we'll come over here and copy that. Paste that in there. Looks like Prometheus is finished.
And you can grab that URL just above the terminal, the flashing cursor, and that'll take you to the Prometheus instance.
Yeah, so now we're here. We can see Prometheus's homepage. Doesn't show any information
and then
yet.
Sorry.
No, go for it, Rusty.
Yeah, there's not anything in here yet. Once we launch the deploy of Silvermint, it'll start spinning up the Silvermint validators. They are all tagged and labeled, and will go and will start showing up in Prometheus via the GC discovery. And then yes, same thing for Grafana.
Yep,
you can copy the URL,
put it in the web browser, and go to the Grafana homepage. You'll notice in the step-by-step here, it shows the default password for Grafana is just admin for user and admin for password. If I can spell admin correctly. I'm just going to leave the password as admin. You can change the password.
You can even click skip if you'd like. Yeah.
Oh, look at that. There's a skip.
Mhm.
Submit it as admin. Alrighty, so you'll see Grafana here, and we can actually see our dashboards. You'll see there's no information because we don't have the network up and running yet. But this is what Grafana will look like. Alrighty, so the Grafana and Prometheus is now set up. Now we're getting to the part where we get to deploy the Silvermint network. So this is our code that we're now going to launch.
That's correct. And let's actually take a minute and walk through this this top block of red you have here. So this is the Terraform variables settings file. We're setting a number of different variables having to do with the operating system of the machines we're going to install. But the ones I want to call your attention to for deploying networks and changing the scale of networks and the locations of networks, things I want to point you at are the GCP region zone map. You'll see a block here. It's 7th down, I think, if I'm reading that correctly. 6th down. Yep. So this is what's called a map in Terraform, and it's mapping the region to the zone. And this is important because your zone map is going to establish what parts of the world you're deploying your networks to. And so because we have 5 zones and regions that we're deploying to, however many nodes we want to deploy should be evenly divisible by that number. For instance, if we wanted to deploy 2 nodes into each region, we would set our Silvermint node count, which is a little further down, to 10. And it would deploy 2 nodes into each region. If that number is not evenly divisible, weird things will happen. But that GCE region zone map is how you define where in the world you would like to have your Silvermint validators deployed. Silvermint node count is the total number of nodes you're going to deploy. TPS per node is a very critical number. This is how much traffic you're going to simulate on the network using what we call senders. And what a sender is it's a transaction simulator. And this is going to create traffic on the network at that number per node. So the initial setting here is really low. And it was intentionally set low because we didn't want to create machines that would have an exceedingly high cost for people who were demoing the network. When you turn this number up, you will need to adjust the validator machine type, which is the last variable. Sorry, no. Yeah, you'll need to adjust that to support the network load. But that's it. You've got your region zone map. You've got your sender machine type, the number of Silvermint node count or node validators you want, the amount of traffic you want to give them, and the number of senders you want to use. We suggest doing the same number of senders as validators as well. But yeah, that's it.
Alrighty.
Could you describe? Am I on? Can you hear me?
Yeah.
Yeah.
Did you describe what a sender is doing versus the validator node?
Not directly, but to an extent, yeah. So we talked about the fact that it's simulating traffic on the network, but so we call it a sender. It's running a tool that's called Simulate, and that Simulate tool generates transactions on the chain to each one of the nodes or the validators on the Silvermint network. And then each one of those Silvermint validators goes to the network for validation.
It's worth noting that I think one of the cool things about the way that that Simulate works is that it actually creates a bunch of wallets and simulates actual user traffic that looks and feels like the real traffic that users would have. So it sends, payments to different amounts of UTXOs, and you can configure it to do payments more or less frequently and things like that in order to achieve different kinds of load effects and see what how the network responds.
Absolutely. Absolutely.
Alrighty, well, let's launch this network. You'll notice this step is run from your deployment workstation, so we're going back to our container here and starting it up. Oh yeah, we need the, you'll notice here again, enter the Google Cloud Project ID. So again, I'm just gonna go back to the dashboard and copy that real fast and paste that in. Alrighty, so now we have another authorization for the Google Cloud. So similar to what we did before, we're going to take this authorization and go to that page.
And while you're doing that, I'll briefly explain why we're doing this step again. The first time we did this, we were authorizing ourselves to interact with Google Cloud. This time what we're doing is we're actually setting application default credentials so that when Terraform runs and it attempts to connect to Google Cloud, it's allowed to connect through our session to Google Cloud. And they are two separate authentication scopes.
Nice and simple though. Just grab that verification code and paste it in our terminal. And now we just let things run.
And I think you're going to be prompted by, yes, you'll be prompted by Terraform one last time. It will show you what it's going to do in Google Cloud, what it's going to create, and give you a chance to say, yes, this looks good, or no, don't do this. That says Terraform not found.
Oh.
That's interesting. Can you do a Terraform? Just type Terraform and hit enter. Interesting. It looks like it did not install Terraform. Plot twist.
That would have been towards the top. These steps here. So I should.
Yeah, you should be able. Sorry, go ahead.
Should be able to just copy that code right there to install Terraform and rerun it, right?
You could. You can also just do an apt-get sudo apt-get install -y Terraform. But yeah, you can copy that code as well.
Huh. It showed us this earlier.
Hold on a sec. Right there, it says the following new packages will be installed. One newly installed.
Terraform is installed.
Bizarre. I'll look into that later tonight, and we'll likely have an update.
Okay, now we can go back to the deployment. Gotta grab that ID again. Oh, I forgot to, whoops. I accidentally hit enter. I'm just gonna,
Oh, I see. Yeah,
let's just stop it.
yeah, it's all right. No, just let it go. It'll
Sorry.
end out there. There you go.
Okay, that was my bad.
Okay. So change direct. I think you need to change directories back.
Okay. Just back to the.
Yeah, let me just confirm. Yes, you'll need to step out of the so cd space dot. Just go up to the parent directory because the code steps you into the Git repository that you've cloned. So yeah, you should be able to repaste that code.
Yeah, so the problem there, that was my bad. I accidentally hit enter twice, which skipped the verification step, so, of the Google authorization.
Just super excited to get to that deployment strategy.
I know. There we go. Look at that.
Yeah, and so this is the Terraform apply kind of pause. You can script in an auto approve, but I really wanted to stop people and have them be able to take a look at what they're about to create here. So if you scroll up, you'll see anything with the green plus mark is being added to your Google project. And it gives you some details about what it's creating, the names of things, etc. But yeah, just simply typing yes and hitting enter launches that Terraform deploy. And so this step, what we're doing is we're in Google Cloud, we're creating a set of Google Instance Group Managers that has a template for a startup script or a template for a machine. And then it is spawning a set of machines that is equal to the number of nodes for that region that it's creating. And we use instant group managers because it allows us to scale up and down very quickly with the exact same startup. When you launch these for actual node operation, you will not be using instant group managers. You'll just be creating a machine, but we're using this for expediency. And there you go.
Yep. And once it's done, it gives you your internal URLs.
Yeah, those are all internal URLs. They're not useful in this context.
Yeah, because when we go back to our VM instances here, and voila. Alrighty, so what we're seeing here is our network, our Silvermint network up and running. You can see Grafana and Prometheus still here, but then you also have your nodes. So we have our 5 validators, and then, as we talked about earlier, our senders, our 5 senders below here. Each validator has its external IP address, as well as you'll find your Prometheus and Grafana external IP addresses. So now, if we go over to, let's just double check the steps, but I believe we're completed. Yeah. This is a really important step. After the step completes, it takes about 5 minutes for the network to come online. And you'll see that in Grafana, where currently
You'll need to refresh one time so that it picks up the actual environment. You can see that on the left for the dropdown where it says Silvermint.
Yep.
There you go.
You'll also see here we're getting some readings for CPU and memory, and it shows that the nodes are not active because right now they're starting up. So this is going to take a few minutes for them to come online and for the senders to start simulating transactions to the validators.
Yeah, and what's happening inside of, or under the hood right now is we're doing an installation from our public app repo, and we're installing the latest version, which at the time of this filming, it's 1.6. And we're doing that coordination step I mentioned earlier with Redis, where we're submitting our IP to Redis and saying, I'm here, and then a script sits and waits for the expected number of machines to check in, and then we're going to start and we'll go. And you'll see that here in just a second. But everything's looking exactly as it should right now. And were you to review the logs or the serial console on any of those validators, you would see it going through and updating the new instance and installing Silvermint, as well as Redis client and a couple of other tools, the Prometheus node exporter, all of that.
Let's look at one of those consoles. Let's show what we're seeing. So I'm just going to skip past all the setup to show where Silvermint is starting.
Yeah, and where you can tell, the lines will say startup-script and will be run by Google Metadata Script Runner. And that's the templated startup that you'll expect to see.
Looks like it's still not.
Yeah, so right now what it's doing is it's creating the multi-tiered storage where we do a write-back caching, which allows us to have very high write speeds, but still have a reasonable cost associated with extended persistence. So that takes a little bit to build all the file systems and build the LVM caching groups. But now we're at the waiting stage, and it looks like we're good to go. We've started Silvermint service. So if you go back to Grafana, what you should see is active nodes
Right here.
have jumped up. Yep. And they'll jump up to the number of nodes that you had indicated in that variables file. And in a moment, you'll start seeing traffic flowing through. Your received per second will go up, and your finalized per second will go up, and everything will begin flowing.
Here it goes.
And like Nash mentioned, this traffic is being generated by Simulate, which is creating a variable set of traffic across all of the nodes themselves. And then all of those nodes are going to each of those nodes is going to all of the other nodes for validation. And so our time to finalization will hover in around the 2 to 3 second mark, even though we're doing thousands of operations. And this network is very small. We're only doing 20 transactions per second per node. So you won't see huge numbers in the receive per second. Nash, what was the large network published speed that we reached?
We were consistently running it at 56,000 transactions a second.
And that
we
was
were
across
able
200 nodes, correct?
Just 100.
Oh, just 100 nodes. That's right.
Yeah. Yeah. So Tallahassee asked a good question. And yeah, the scalability's been really good with just 100 nodes. Like I said, we've been able to do 65,000 transactions a second. And so we should be able to scale to 150,000 and beyond with a reasonable decentralization. And of course, it's a proof of stake network, so the security is as good as the staking is. We're pretty confident that it's going to work out, and that we'll address all 3 legs of the trilemma as well as, or better than everybody.
Yeah, it's pretty remarkable. When we were running at that 56,000 transactions per second, our time to finalization was still under 4 seconds.
Yeah.
So the scalability is, I mean, to be honest, it's exciting.
Yeah, and that was with nodes in China and Europe and everything.
Yeah, all over.
That's correct. Yeah, and that's actually something that's worth pointing out. And I know we looked at the region map, and maybe we didn't pay a lot of attention to where these are landing, but each one of these nodes we created are in a different part of the world. We are in Belgium, we're in Hong Kong, and we're on East and West Coast, and then Central of America. So this is truly a global network that's operating right now. No, it's operating at low speeds, yes, but we were running 56,000 transactions per second across 100 nodes spread across those same 5 regions. That is exciting.
Yeah, for sure.
And there's some, as well as this information here, Andrew, go ahead and jump into the Silvermint folder on Grafana there, and let's show a little bit of the the metrics catalog. So this is what we call our metrics catalog, but essentially it is a series of panels based on components within our code. And each one of these is a set of information that's being produced via Prometheus. And so you have an extremely granular and powerful view into what's happening in the network and what aspects of the network are functioning and at what rates. This has been absolutely critical for us in our troubleshooting process as we're developing and engineering things. This has been extremely, extremely helpful. And it continues to grow. As we go through and add new features, we add new metrics and new data. So
yeah, we use them all the time.
Pretty awesome part of this.
Yep.
We also have our, oh, never mind.
Yeah.
Just the metric on that one.
Yeah, we can go back to global network metrics. We reduced the number of dashboards, Andrew. You were expecting to find a couple other dashboards. Yeah, we reduced the number that we deployed.
Kept the good ones, the ones you need. Alrighty. Well, this is just going to run, so let's look at the other steps in our document here. Just talking about cleanup and removal. You can just simply delete the Google Cloud project. There's just a little link here that'll bring you to your resource manager, making it so you can go in and just delete it. So, and then references. So that's the step.
Yeah, and that kind of brings us to the end of the process.
Yeah. Alrighty. Do we want to discuss anything else?
Has everybody have we shown enough of the console to show transactions and maybe just bring it up the console and walking through what the different charts mean so people that run it on their own will know what they're looking at?
And by console, you mean the dashboard?
Yeah, sure.
Yeah, sorry. Good console, I think terminal. Let's go through each panel. So we've kind of grouped things into sections. Top left of the dashboard is your transactions. And we break that down into received per second, time to finalization, and then finalized per second, and pending. And we have a left and a right graph on these top two rows. And one is an aggregated single line, and the left is an aggregated single line, and the right is a line for each node that's in the network. And so when you increase the numbers here, you'll actually be able to see very easily if there's one bad behaving node or one node that's operating very differently than the others. And what we find is that it's extremely consistent. So we provide this because it's a good troubleshooting and diagnosis tool. But what we see is that it's extremely consistent across the board. So our receives per second, you can see that each one of those machines is handling about 14 transactions per second. You'll notice it's a little lower than the stated 20. Simulator does its best to hit that target, but it ends up being a little bit lower than the number given. The next row is the time to finalization. So this is how long it takes for a transaction to be completely finalized or to be. Nash, I think you could probably explain that better than me. I'm on the operations side, but for it to be finalized on the network, and so we're averaging a very solid 2.2 seconds. And you can see the little wave that's occurring there. it's going to just smooth out and stay right there. The next down is the actual count of transactions per second that are being finalized, and we show that graph on the left-hand side for each node. And you see it's hovering around 65 to 70, almost 80 per second. And then on the right is the number of transactions that are in a pending state at any given time. And you can see that that ranges from 3 to 15. Below that is the blockchain section. So this is the number of blocks that we've added to the chain since the network started. Any rejected blocks we receive, that counter will show that, and then the rate of block production. And our block timer is 1 per second. So each one of these machines should produce 1 block every second. And so this should be a very flat graph at exactly the same number as nodes that we launch. And then in the right column there is network statistics. And so we have an idea of how long the network's been up and running in the uptime panel. Below that is the count of active nodes. And below that is an aggregate average or an aggregate of the CPU utilization across the hosts and the memory utilization across the hosts. And you can see they're both very low. Again, this is a very low speed network. But what we've seen is that our memory utilization is very flat. Even at our 100 node, 56,000 TPS, our memory utilization stays very flat. Below that is network bytes per second. This is an aggregate across the network. So we're running 22 kbytes per second. And then the percent of block bytes used for consensus. This is how much data is related to the consensus protocol that's coming across the wire. Ash, was there anything else that you wanted to point out here?
That number that you just showed, was that the percentage of block bytes used for
block bytes used for this? Yeah.
Yeah. What's it at? I can't see in my windows.
36.6.
36.
Yeah, 36.6%.
Yeah. At load, like when the reason that it's that low or that it's that high right now is because this network isn't really taking any traffic. Just a few transactions per second, but at transaction rates 10,000 and above, that number drops down to like 1%. And part of the reason that we're so fast compared to other networks is that our protocol takes much better advantage of the bandwidth that's available. We use very little of it for consensus finding. We're able to do it with just a very compact little array of integers that represent the DAG structure. And so right now it's large compared to the number of transactions because there's no transactions in the blocks, but yeah, under load, it's really super efficient. It's very impressive. Well, I think if you guys don't have anything else, I don't think I have anything else.
Yeah, I think we're good.
Yeah, I think we're good.
Yeah, I think
Thanks
we're
to
good
everybody
too.
who joined and commented and asked questions. And we'll be back next week at the same time with a development update. And so tune in then.
Yeah, and just before we stop the stream, I just also want to say if you enjoyed what you saw here and you're excited for those community updates or the development updates, you can follow us here on Kick. If you're viewing right now, just make sure you give us a follow. That way you can see when we go live. Otherwise, you can check us out on YouTube at Silvermint, where we'll be posting the video after the fact, and you can check it out whenever works best for you.
All right. Thanks, everybody.
Thanks, everyone.
Thank you.
See you soon.